Good afternoon, guys. This is Saturday, so I figure I'm going to be a little rebellious and not dress up today. Hopefully, you don't mind. So today we are going to talk about Chapter 5 discussion. Okay, or sorry, Unit 5 discussion. Okay, so Unit 5 is on aggregate demand, and it is actually a very technical chapter in this entire semester. So as we go over these things today, I hope you will pay attention. Maybe pause it and um, try to digest the knowledge and then move on. Take it slow. If you have questions, write it down, and then we'll talk about it on Wednesday. Okay. Now, aggregate demand, as we've explained before, is the overall demand that we consider for everything the economy, everybody in the economy wants to buy, right? And so it represents the total spending in the economy, okay? Now, if you recall, the expenditure approach or the spending side of the approach of GDP is your GDP equals C plus I plus G plus net exports, okay? Now, in this chapter, we will essentially take these four different parts and explore them individually, okay, one at a time. And so C, let's start with C. C, if you remember, stands for consumption, okay? Consumption, we said, comes from private spending of households, okay? So people, this is what consumers spend. Now, instead of just looking at a sum of dollars, saying this is how much consumers are spending this year in our GDP, what we can do now is to look at what affects consumer spending, okay? So this leads us to what's called a consumption function. A consumption function is a mathematical equation that tells you what consumption equals to, or where consumption comes from, okay? Now, on an individual level and on the national level, the consumption function is exactly the same. The only difference is on the individual level, we use lower letters because it's the personal situation. On the national level, we use capital letters. So let's start with individual one and look at how this works, and hopefully will help you understand it, okay? So the consumption function is an equation that's consumption, little c, equals something called A plus, okay, something called MPC times your disposable income, so Y with a subscript D, okay? So let's talk about each piece here. Okay, C is consumption, we already know that. So again, this is on the personal level, so personal consumption of somebody, okay? A here is something called autonomous consumption, okay? Now, one thing that is true for this class is that whenever you see the word autonomous, okay, it means independent of something, and in this context of this class, it always means independent of income or independent of real GDP, which is the income on the national level, right? So, so on the lowercase personal consumption function, little a is autonomous consumption, meaning your consumption independent of your personal disposable income. And when we capitalize all these letters, then the capital A is the autonomous consumption for the entire economy, so that is independent of national income or real GDP. Okay, now I know that saying autonomous consumption or independent of income consumption still doesn't make sense. So let's look at what we mean here, okay? So what A is that if your income, your disposable income is zero, okay, if you don't make any money, okay, then your consumption function becomes C equals A plus MPC times 0. Well, anything times 0 is 0. So this whole term goes to 0. Then what you have left is C equals A. Okay. What this means is, well, A is the amount of consumption you need even when your income is 0, when you have no income at all. You might say, well, wait a second, if I have no income, how can I consume? Well, this is the idea of what you have to spend on necessities in life, right? Because in fact, I think some of you might be in this boat where you don't have a job and your income is 0, yet every month you still eat food and you still have clothes to wear and you still have some kind of roof over your head and you pay rent, right? So you spend money even when your income is 0. And that money you spend when you have no income is what we call autonomous consumption. And again, this is consumption that happens even without any income, or we call this spending on necessities to sustain life. So the technical term in economics is called autonomous consumption. Okay, again, autonomous means independent of income in the context of Econ 151. Okay, so I hope that makes sense. So we said, okay, consumption, okay, first of all, comes from autonomous consumption, which is what you have to spend without income, okay, and then the MPC times Y, the second part of the plus sign here, okay, so A is called autonomous consumption, MPC times Y is called induced consumption, okay, so that means this is your consumption that does happen with income, okay, it's induced by income. So MPC here stands for marginal propensity to consume. Okay, marginal propensity to consume means the proportion of your additional income that you spend on consumption. Okay, so the proportion of your additional income that you spend on consumption. And mathematically, MPC equals the change in consumption over the change in disposable income. Okay, the change is key here because MPC does not, okay, does not equal C over YD. Okay, that is not the case. Okay, this is wrong. It's always the change in consumption over the change in disposable income. So that's saying whenever you have more income, additional income, how much of it are you going to spend on consumption? And that number you get here is what we call the marginal propensity to consume. Since it's a proportion, okay, your MPC is going to be a number between 0 and 1, right? Because 0 means you spend nothing out of your new income on consumption. 1 means you spend everything, all of your new income on consumption, or somewhere in between. So it's always this number between 0 and 1, okay? And if it's 0.7, that means when you get new income, you spend 70% of it on consumption. The rest, what do you do? Well, if you recall, okay, this leads to the last component here, okay, which is disposable income. Okay, again, disposable, okay. We said disposable income is after tax income. So what you can dispose of, right? So this, there are a couple ways of looking at it. How you dispose of it? Well, we say disposable income equals consumption plus savings, right? You either consume it or you save it. Okay, you've seen this equation before. Or since we said by definition, it is income after taxes. So it's the total income you have minus NT of net taxes that you actually pay. Now, this is all on the personal level, so I'm using all lowercase letters, but the same equations hold for national level, so you just need to capitalize these letters and you get exactly the same things measured on the national level, okay? So then here, okay, MPC times YD, okay, gives you the proportion of your disposable income that you're spending. So that is what we call induced consumption, right? So that's how much out of your income you're spending on consumption. So that means the total consumption C equals what you have to spend to sustain your life, plus whatever you can afford to spend given your income, which is MPC times YD, right? Together, that's your total income. Total consumption, okay? So that's the consumption equation and what it means. I hope that makes sense, okay? Now, let's look at the graph of how this works, okay? So the consumption function graphically, you have consumption here, okay? Disposable income here, and it's gonna be an upward sloping curve, something like this. So this is your C equals A plus MPC times YD, okay? Now, the slope of this line, the rise over run, is gonna be your MPC, okay? And then here, this point is what consumption, what C is given YD being 0. So this is actually your little a, okay? So little a is what you have to spend even when your disposable income is 0. What do you have to spend on consumption? So that's what it looks like graphically, okay? Now, before we talk about anything else, then let's talk about something closely related to this, right? Because we said out of all your disposable income, you can either spend it, which is consumption, or save it. So related to this, you also have a savings function, and the savings function is negative A plus something called MPS times YD, okay? And here, S is savings, A is also your equals to your autonomous consumption, but here it's negative A, okay? And then MPS stands for marginal propensity to save, and then YD is still disposable income. So let's talk about what this means here for a second, okay? So here, negative A, first of all, okay? This is the amount of savings you have when your disposable income is 0, right? Because if YD is 0, MPS times YD is 0, then all you have left in that case is S equals minus A. So that's this is saying that when your disposable income is 0, you know you have to spend A to sustain your life, and the A has to come from taking away your savings, right? So your savings would be decreased by A when you spend A with 0 income, right? So because we said A is your autonomous consumption, that's what you have to spend on necessities. So when your income is 0, you spend A, but since your income is 0 and you're spending A, that has to come out of your savings or borrowing. Either way, your savings is gonna decrease by A. So that's why S equals negative A first, then plus MPS times YD. So MPS, okay, we said marginal propensity to save, this equals how much you save out of your new disposable income, okay? Or another way to look at it is that since we said your disposable income is either spent or saved, then this also equals 1 minus MPC, okay? Because MPC and MPS will always add up to 1, right? Because the proportion you consume plus the proportion you save should be your entire income, okay? So that means then you also have a savings function, and the savings function, so you have savings here, 0 here, disposable income here, okay? It's gonna look something like this, where, okay, your slope here is MPS, okay, the proportion you save out of your disposable income. And then the intersect here, you can see is what savings is when your disposable income is 0, that is negative A, okay? So that's what savings function looks like. It's closely related to your consumption function, okay? Now, The next part of the question is, well, what shifts your consumption function? Right? Your book has a good list, but let's talk about a couple to help you understand, okay? Again, as a general rule here, what we're talking about is the difference between shifting your curve and moving along your curve. So if your income changes, does that shift your curve? Well, I hope by now you know that, well, income is on your axis. It's part of your model here. So when income changes, it is only going to move you along the same curve, right? So if you get a raise, you make $1,000 a week now instead of $800 a week. All that's going to do is to take you from one point to another on your consumption function, right? So that's saying that, okay, so here let's call this point A. Okay, oops, that I meant to do this. Get rid of this. Never mind. Okay, so let's say you were at point A, which was you're making $800 a week, and your total consumption is, I don't know, let's say $600 a week. Now you're making $1,000 a week. Call this point B right here. Okay, and that means now you're spending, I don't know, $700 a week or whatever, right? So the point is, when your income changes, it's simply moving from one point to another on the existing curve. So the curve itself does not change. You just move along the line, okay? So income changes do not shift your consumption. So you might say, well, then what does? Okay, it's anything else that affects your consumption. That's not an income change, right? For example, one thing is net wealth. Okay, so net wealth is your total assets minus your total liabilities, and income is only part of your assets. So when your net wealth changes while your income doesn't, you're going to consume at a different level, right? Let me give you a quick example. Let's say that you wake up tomorrow and you get a phone call, and at first you thought it was a joke, but then you verify it's actually true, that some lawyer in England is calling you because you did not know you had a distant uncle in England that's a noble and died and left a castle and bunch of estates to you. So you might still be working at Five Guys in Rexburg making $10 an hour, but now you own a few £100 million worth of assets in England. Guess what? Okay, in that case, your consumption function is going to shift up, okay, to a new level. And that's saying that even if your income is still at $800 a week, all of a sudden, okay, you're going to spend $800 a week now, right? Or whatever the case is. You're going to spend all of your money because, hey, guess what? I got 200 million pounds worth of real estate and other assets and jewels in England, so I'm okay, right? And so with this kind of shift, the whole curve parallelly shift upward. So that means it's really the slopes remains the same, but the intersect becomes different. So that means when your net wealth increases, what you view as necessities of life will change on every level of income you are, right? So you have, yeah. So you used to be able to live off of ramen noodles. Now you feel like, you know what? Every week I gotta have a prime rib. Okay, ramen noodles just won't cut it. Okay, so that's what can shift it. Okay, and another thing is the price level, right? When things become expensive, then you can't afford to buy as much. So a higher price level is going to shift your curve downward. Okay, and also the interest rate is another one, because when the interest rate is higher, you are more likely to save. So the more you save, then that means the less you have to spend, right? Because we said savings and consumption both come out of your disposable income. So when you save more, you have to spend less, assuming you have just a fixed amount of income, not infinitely increasing income. So this higher interest rate will also cause your curve to shift downward. Okay, and then expectations can shift that as well, right? So if you expect that your income is going to decrease in the future, so your income hasn't changed yet, but you expect it to change. That expectation will change your current behavior. So your income is still $1,000 a week, but now instead of spending $700, you're going to spend $550 because you're trying to save for the rainy day that's going to come next year, right? Or something like that. So those are some of the factors that will shift your consumption function, okay? Now, the last thing about consumption we want to talk about is simply put your life on a little graph and show you, okay, what happens over time, okay? Now, so this is consumption, this is time, okay? Your whole life on a graph where, you know, your consumption will start fairly low because starting out life, your income is fairly low, okay? And then you hit a point where your income is gonna jump up, okay, hopefully dramatically, and then it's gonna continue to rise, and then, whoops, after the retirement, okay, it's gonna drop to a certain level. And well, so this is your income, right? So this is your income, or I should say here, let's use YD, okay? So your income for your whole life looks something like this. Your consumption, okay, should look like this, fairly smooth, okay? Where at first, okay, your income is lower than your consumption, so all this is borrowing, right? A lot of you are in that situation right now. Your income is less than your consumption, so you have to borrow money, get student loans, and etc. Okay, then once your income falls higher or rises higher than your consumption, then this is all of your savings, the difference between your income and how much you spend. And hopefully your savings is big enough to pay back all this borrowing. And then you can see here, the sharp drop in your income here. This is retirement, right? So time-wise, this is retirement. Okay, so if you have saved enough, then you can see in retirement, your consumption then can stay higher than income, so you can hopefully have enough left over to fund this part as well, so your standard living does not significantly drop once you retire, right? So that's the idea of what you should do with your life on one simple graph. Anyway, so that's consumption. Okay, I hope that made sense. If not, like I said, write your questions down and we'll talk about it. Okay. The second is investment. Okay, so we talked about C, now let's move on to I. Okay. Now investment, by the way, I guess I forgot to mention, consumption is the most important one, and we went into so much detail about it is because 67% of our GDP is accounted for by consumption. So it is a huge chunk of our GDP. And investment is only 16, 17%. It's not a very large share of our GDP, but it's the most volatile, okay? And the most volatile means if you look at what happens to our real GDP, so our Y, our economy, over time, whoops, this is not zero, okay, time doesn't start with zero here, okay? And our real GDP generally goes up and down, up and down, up and down like this, but overall it's generally an upward trend, okay? So if you do a fitted line through it, you can see overall it's growing, even though it have ups and downs. Now, this is what Y looks like. If you were to look at what happens to investment, it follows the same pattern, but the swing is much bigger, right? So it goes something like this. Okay, so investment follows the same pattern over time, but it's much more volatile. And because of that, we need to pay close attention to what happens to it as we go through our economy. Because if investment is dropping sharply, that's an indication that GDP is likely to follow. Okay, so even though it's not a big chunk, we care about it. Okay, so Now, as a reminder, there are only 3 things in economics we count as investment, right? So we've talked about this multiple times before. The first thing is purchase of any physical capital, okay? Okay, so any money firms, so investment is spent by firms. Any money firms spend on physical capital is investment, okay? And 2 is any new buildings, so including private residences in this case, right? So any new factories and new malls and new homes, those are also viewed as a new building, investment. Then finally, okay, is inventories. Okay, so these are things that have been produced but have not been sold yet, right? So only these 3 things are considered as investment in economics. Nothing else is. And so remember that, right? So buying stock and gold and Bitcoin, those things are not considered as investment, okay? Now, when it comes to investment, we're trying to make your life a little bit simpler. So we assume, okay, investment is autonomous. Okay, now I'm gonna pause for a second and ask you to remember what autonomous means, right? So investment is assumed to be autonomous. Okay, hopefully by now you remember autonomy means independent of, and we said in this class specifically means independent of real income or real GDP, okay? So on the national level, okay, if you look at investment and real GDP, investment being autonomous means once firms decide how much to invest, okay, let's call this, I1, and let's say firms decide to invest $1 trillion, okay, then that's it. Okay, once they decide to invest 1 trillion, doesn't matter where real GDP is. Real GDP can be 10 trillion, real GDP can be 20 trillion, real GDP can be 30 trillion. Doesn't matter where real GDP is, firms are going to invest 1 trillion. So investment is assumed to not be affected by a real GDP, by Y. Okay, now you might say, okay, so what does affect firms' decision of investment? Well, here we assume there's only one thing that affects investment. Okay, again, for the simplicity of your life and still without hurting your understanding of how the economy works, we say, okay, investment, how much firms actually invest depends on one thing, which is interest rate. Okay, so and the investment demand curve looks something like this, just like any other demand curve. It says, well, when the interest rate is really high, call this IH for high interest, then you can see the investment amount is going to be low, okay? Call this IL for low investment. And if the interest rate becomes low, okay, so then investment will become high. Right, so that's what this relationship is. Now let's think about this for a second, right? So we said in class before, most investment happens with borrowed money. So interest rate measures, okay, how much cost there is to borrow money, right? And hopefully this makes sense. If interest rate is really high, then that means it's costly to borrow money to invest. And if you have to pay high cost to borrow money, then that means the returns, the chance for you to make a profit off of your investment is going to be low, right? Because the more interest rate you have to pay the bank, then the less of a chance you're going to make a profit off of your investment in the future. So few investment projects will be done, okay? But if interest rate is low, okay, then that makes borrowing cheaper. So firms are more willing to borrow and take that risk on investment. And so a side note, that's why the Federal Reserve, whenever there's a recession, they try to push the interest rate low, as sometimes down to zero, right? And recently there has been some talk about, well, whether we should push interest rate to negative, right? So now you know the idea of real interest rate from your previous test, and when we talked about inflation and interest rate, right? Or maybe not previous test, it's your previous chapter, previous unit, okay? So real interest rate can be negative pretty easily, but nominal interest rate, we have not seen it to be negative, okay? Nonetheless, okay, if you need to borrow money to invest, hopefully this negatively shaped investment demand curve makes sense. Now the question I want to ask you is, well, what if you have cash, right? You are a very frugal business owner, and instead of expanding quickly, you have saved up for years, and you actually have cash to invest, to build a new building, a new factory with your own money. If that's the case, do you still follow this kind of downward sloping demand curve for investment? Okay. Now think about that for a second. I think some of you might say, yeah, some of you might say, no, if I have money, then I'm not going to be affected by interest rates. Well, the key here is to think about what happens to your money if you do not invest it, right? So if you do not invest it, a lot of people say, well, I save it, okay? So by saving, actually, you mean you let other people borrow it, right? Because any kind of savings that bears an interest rate you earn, that means somebody else is borrowing your money and paying you, right? So even if you put your money in a bank and they give you 1% on your savings account, that is because the bank has taken your money and loaned it out to somebody else, and that person is paying 5% interest rate. So the bank is paying you 1 and keeping the difference of 4 for themselves using your money, right? So we'll talk more about how banks and the banking system functions in future chapters, but that's essentially what your alternative is, right? If you're not investing your own money, then you have the opportunity to let others borrow and earn an interest on that. Well, if that's the case, then the interest rate here becomes the opportunity cost of investment, right? Because if you choose to invest, then you miss out on how much interest you could collect with the cash that you have. So in that case, if interest rate is high, okay, meaning that you could earn quite a bit by lending your money to somebody, then you're still less likely to invest, right? So if somebody could pay you a lot of interest for borrowing money from you, then you probably won't spend the money yourself on investment, okay? Now, on the other hand, if interest rate is really low, okay, you can't really earn anything by letting other people borrow it anyway, then you're more likely to invest. So this relationship of high interest rate and low investment and low interest rate and high investment still exists. So that means even if you have cash, you still follow the same investment demand curve that's downward sloping like we drew here. Okay, so this investment demand curve holds for any case, whether you need to borrow money or you already have cash to use yourself. Okay, so make sure you understand that. Now, so that being said, then interest rate is the only thing that can shift your investment function, your autonomous investment function here. Okay. So this is called autonomous investment function. Okay. And this is your investment demand function. Okay. So when the interest rate drops from IH to IL, high interest rate to low interest rate, investment is going to increase from low investment to high investment. So over here, if this is the low investment we started with, what you're going to observe as that interest rate drops is that investment is going to rise to a new level, okay, let's say $2 trillion because of lower interest rate. Okay, so that's the only thing we assume investment responds to in this model. Now you might say, well, in reality, I just don't think that firms don't care about what's going on with real GDP. Okay, now that's not entirely true, right? Firms, once they make the plans to invest, usually don't care about what the current real GDP is, but they do care about the expectation of what is going to happen to real GDP, right? So if real GDP today changes, fluctuates ups and down, firms usually don't know about it, or they don't care about it too much. But if somehow firms believe real GDP is going to take a big hit in the near future, then there might be some reduction in investment. So it's the expectation that could also shift your investment function here, okay? All right. Okay, so that's investment. Okay, now the third one is G, government spending. Okay, that's a terrible G. Okay, now government spending or government purchases. Okay, first of all, we said it's also autonomous. Okay, so meaning that the government, once they decide how much to spend, it does not depend on where real GDP is. Right, so if they decide to spend this level of spending, real GDP can be high, real GDP can be low, they'll spend it anyway, right? We should all know that our government really doesn't care about what's going on in the economy when they spend money, okay? And so that's what it means by G being also autonomous, okay? And also, we say G does not include transfer payments. We mentioned this before, right? So G does not include transfer payments, which is what TR stands for. Okay. Now we said that's because GDP records the demand that induces production, the actual production of something. Okay, transfer payments is just taking money from one group in the economy and giving it to another group. So taking money from me right now and giving it to people who have lost their jobs, who are unemployed. So in this process, there's no production involved. The government simply takes money from the working class and give it to the people who need help. So no production involved, thus we don't count it as part of GDP. So that's why it's not part of G, even though it's a government action and manipulating money. Okay, and also net taxes, we said are not part of government spending, and that's actually government income, right? And so taxes, we'll talk about in the next couple units of how taxes can change real GDP eventually, but the fact that the government raises or lowers taxes does not get counted as part of our GDP for the same reason. There's no production involved in this case. Okay, so that's government spending. And just to review, budget balance, okay, is your net taxes, the income for the government minus the spending for the government, right? That's how you do budget balance. BB stands for budget balance, okay? All right, then finally, okay, net exports. Okay, so net exports, there are several things that can affect how net exports work. Okay, remember net exports we said is exports minus imports. Okay, so it's the difference between what we sell to other countries and what they what we buy from them. Okay, now there are several things that can change net exports. First is an income. Okay, so if somehow, let's say, the income in the U.S. doubles and no other country's income changes, what do you think is going to happen to our net exports? Well, in this case, if income increases, okay, and our income increases and other countries' income doesn't, so that means we will buy more with higher income, right? And when we buy more, some of it will come from other countries, so that leads to an increase in imports, okay? And since other countries' income doesn't change, so exports don't change for us. So if exports don't change and imports increase, that means our net exports is going to decrease, okay? I hope that makes sense, okay? Another thing can be, something, let's say the US has inflation, okay, higher than other countries' inflation. That means our prices or our products are becoming more expensive and faster than foreign products. So if that's the case, similarly, will buy more from other countries because other countries' products are relatively cheaper. Okay, and also in the same time, because U.S. products keep getting more expensive, exports are going to decrease because other countries won't buy as much of our more expensive products. So overall, net exports will also decrease, right? And another thing can be the exchange rate. Okay, so if the exchange rate often is denoted by E. Okay, if let's say actually, let's do this. Let's say if the dollar appreciates, okay, so that means the dollar is becoming more valuable, okay? If the dollar is becoming more valuable, that means foreign products will become cheaper to us relatively, right? Because every dollar can exchange more foreign currency. That's what dollar appreciation means. So foreign products will take fewer dollars to buy. And so that means our imports are gonna increase. Similarly, a dollar appreciation means American products will take more foreign money to buy, so foreigners can afford less US products, so exports is going to decrease. And in that case, net exports is actually going to decrease, right? So this is a side note related to this is, sometimes people who don't understand economics think that the dollar appreciating is one way to show the strength of our economy and even ties into national pride. So people push for the dollar to appreciate, and if dollar up depreciates, then they cry wolf and saying doomsday's coming. But in reality, a strong dollar actually lowers our net exports, which in turn lowers real GDP, right? So it's actually not necessarily good for us. It's good for your pride, right? Feel like, yeah, America's strong, but from an economics perspective, okay, it doesn't help our GDP with a strong dollar, okay? All right, okay, so that's the 4 different components, okay? Now, the last thing I want to cover is the spending multiplier. Your book also spends quite some time on the income and expenditure model, or also called the Keynesian cross. That's the graph with a 45-degree line. About a year ago, I decided to eliminate that part from this chapter because I realized that if students can understand that part, it really strengthens their understanding of aggregate demand. But most students just don't get it, and it confuses them more than helps. And you can still understand aggregate demand without understanding the income expenditure model or the Keynesian cross. So if you read about it, great. If you understood it, even better. If you did not read or did not understand it, don't worry about it. I am not expecting you to understand that specific model. Now, the rest of the chapter is still relevant and important, but that particular model, you can just not worry about it, okay? So let's look at the last thing we want to talk about in this chapter, which is called the simple spending multiplier. Okay, now the simple spending multiplier refers to this fact that whenever you spend a dollar, it does not grow real GDP by only a dollar. It can grow real GDP by several dollars. Okay, this process is called the spending multiplier process. And you might say, well, wait a second, how does that work? How can I spend a dollar and grow real GDP by more than a dollar? Well, let me give you an example, and hopefully you can understand this process better, right? So in a unique way, a unique thing about an economy is that every dollar you spend becomes somebody's income, okay? So no dollar spent just vanishes, right? And so let's say that, today is Saturday, you just went to Brolem's and you bought $100 worth of groceries, okay? Now the $100, once you spend them, they become Brolem's income, right? Specifically, let's say Brolem's uses the $100 you just spent to pay one of their employees. So it became that employee's income, okay? Then this employee, once they receive the $100, they're not gonna just hold on to it for warmth or put it under the pillow to feel better at night, right? They're gonna spend some of it. Maybe not all of it, they may save some, but they're gonna spend some of it. Let's say that this employee spends $80 on a new pair of boots, okay? So that means the $80 that came from your original $100 spending will go to the boot store and become their income, right? So the the shoe store owner makes these $80. And now let's say the shoe store owner takes his wife out for their 20-year anniversary on the $80 and spend it at their, or actually, let's say that the shoe store owner also saves them, right? Only spends 80% of it. Okay, they don't spend it all. They only, their MPC is 0.8, so they spend 80% of the $80. So 64 bucks. So this shoe store owner takes his wife to, I don't know, let's say Texas Roadhouse for their 20th anniversary, spends $64 on buying a meal. Again, the $64 initially came from your $100 spending at Brolam's, okay? But now it's being used to purchase this meal, and it becomes the restaurant's income. And then whoever earns that at the restaurant will then spend some of the 64, and et cetera, and et cetera. Now, every time this money is being spent, it creates demand for new transactions and new production, right? Because you bought groceries with your $100, and then the Brolam's employee bought a pair of new boots with $80 out of your 100, and then the shoe store owner spent $64 out of the 80, which came from your 100, on buying food. So every time this money is used to buy something, it's recorded as new GDP transactions, right? So your initial $100 spending can be recorded several times as new transactions happen. At the end, the total growth in real GDP as a result of it is not only your $100 of groceries, but it's $100 groceries plus $80 on shoes, plus $64 of a meal somebody consumed, plus et cetera, et cetera. So the total GDP change is much bigger than your $100 initial spending. So this process is called the spending multiplier process. Now, the spending multiplier specifically measures how big this process is, right? If the spending multiplier equals 5, that means every dollar you spend will grow real GDP by $5. If it's 8, that means every dollar you spend will grow real GDP by $8, okay? So the spending multiplier itself, okay, the equation is 1 divided by 1 minus MPC, okay? MPC is your marginal propensity to consume. In fact, MPC is gonna be the single most important piece of information that you're gonna need for the next many chapters and units. So make sure you understand what it is and how it works, okay? So the full formula for how this works is that the change in real GDP, Y, equals, okay, some initial change. So any part of real GDP can be the initial change. It can be a change in consumption, or a change in investment, or change in government spending, or change in net exports. So any of these 4 can happen. So whatever the initial change is, multiplied by the multiplier, okay? So for example, okay, let's say that because of the coronavirus, okay, investment has decreased by $10 billion, right? Companies are worried about what's gonna happen to our real GDP in the future. So their expectation has changed. So their investment decreased. If that's the case, the change in, and in the same time, let's assume the MPC for America, for our overall economy is 0.8, okay? So that means if you take the American society as a whole, when we make more money, we spend 80% on average, okay? So if that's the case, we can figure out, well, what is the effect of firms spending $10 billion less on investment will have on our GDP? So the change in Y is going to be negative 10 billion, remember, because this is a decrease of $10 billion, times 1 divided by 1 minus 0.8, okay? And that equals negative 10 billion times 1 over 0.2, which is negative 10 times 5, and that gives you negative $50 billion. So that means a $10 billion decrease in investment will cause a $50 billion decrease in real GDP, because when the investment decreases by 10 billion, it does not just kill the $10 billion project, but it killed the income for people who would have worked on that project and earned the 10 billion, and then what they could have done with that money in spending, right? All the future cycles of spendings were killed because of the $10 billion initial project is gone. Okay, so real GDP, as a result of it, decreases by 50 billion, so it's multiplied 5 times. Okay, now you can do the increase case, right? If government, in this particular case, right, the government increased spending a lot to help save the economy, and then that will also go through the multiplying process. And you know, if the government spends $10 billion, then the real GDP in this particular example would increase by $50 billion, right? So that's why the government often throws money into the economy when things go bad, because they're hoping to kind of, you know, start the economic engine. Okay, and we will have plenty exercises with this and in the future. Okay, now this concludes today's lecture. So hopefully things make sense. If not, like I said, watch it again, digest it slowly, and write down your questions. And I will see you guys on Wednesday. Bye.